Good day, everyone. I'm Nidhi Pabari, and here are my teammates Fareen Khan and Sanika Tabte, and we are presenting our project Craft Comfort. This is the agenda for today. Have you ever bought furniture online only to discover it doesn't quite fit or match your space? I certainly have. Like when I purchased a flower stand that ended up being too large for its intended spot. These common challenges inspired the development of Craft Comfort, a smart automation solution for online furniture shopping. It incorporates augmented reality for virtual tryout, recommendation based on color and space aesthetics, and personalized user experience based on user profile and feedback. Summary of the literature survey. We have found research papers in four main domains: augmented reality, content based recommender system, collaborative based recommender system, and color analysis. From these research papers, we have seen whether they have used AR or not, whether user feedback is considered, if color analysis is done, and whether testing is done or not. From the above research papers, we have observed three major gaps in literature survey. The first gap is color-based recommendations. The second one is incorporation of user feedback. And the third major gap is testing. Problem definition and objective. To develop an augmented reality based furniture shopping application enhanced by a recommendation system that considers the user's profile, including age, gender, etc., incorporates user feedback, and also accounts for spatial and color aspects. Now, Sanika will say the system architecture.
So I'll brief you the systems architecture. So first, the user begins by signing up or logging in. If it's the first time user, then we start by asking him some questions regarding his age, his occupation, gender, his income. We store this data into a user's database. Apart from that, we are also maintaining a furniture database. In that database, we are keeping information about the furniture attributes like the dimension of the furniture, the material of the furniture, and etc. We use these board database and we feed it into a hybrid recommender. So once the user is done by logging into his account, he is then guided to the home page where we show him furnitures which are recommended by this hybrid recommender. The user can then browse through the furniture, and if he likes a furniture, we have an option to visualize his furniture into his space. So we have a feature of view in AR. The user can select that and then visualize his furniture. After that, if the user then further wishes to get recommendation based on his room context, then we ask the user to provide an image of his space, and along with that dimensions of the uh, space available in his house. Then we feed this data to a content-based recommender and show recommendation based on his room context. After the user is done viewing his uh, furniture into the AR, he can then also in, he can then wishlist those items, add them to the cart. These activities are also captured and stored into a user database. After that, we are also asking him to rate our recommender and using this for testing our recommendations. So this is the systems architecture. Next slide. Okay, so the hybrid recommender is a combination of content-based recommender and collaborator. The way the content-based recommender work is the user starts, then he browses through the furniture catalog. He adds items which he likes to his wish list on cart and into his cart. These items, then we find similarity of these wish listed items with the furniture present in our database. Using cosine similarity, we find similar furnitures, and based on the top furnitures with highest similarity, we recommend those end furnitures. Next slide. Collaborative filtering. In collaborative filtering, we take the current user and then we find other similar users from our existing database, again using cosine similarity. Then we analyze the wish list of those top and similar users. And then we analyze what are the furnitures which were wishlisted or added to cart by those top users. And again, we sort them and recommend top and most occurring furnitures. Now, we combine both content-based recommender and collaborative-based recommender into a hybrid-based recommender. And this is how the architecture of hybrid recommender. Next is color recommender, and Fareen will explain that.
So, hello, this is Fareen Khan. So, continuing with the system architecture, this is the part where we make recommendations using the image of the room. We first extract top 3 colors from this image, and this is done using MMCQ algorithm, which is short for modified median cut quantization. And then we map those colors to obtain our final color palette, using which the furnitures to be recommended are filtered out. So the slide basically shows the mathematics involved in the process. First, let us look at the MMCQ algorithm. We are defining D as a set of dimensions. Here, D contains RGB, that is red, green, and blue. So LD is the length of D, that is 3. Now take a look at the colorful cube. So this cube that we see on the slide depicts something known as the V box. This may not necessarily be a cube, rather more often a cuboid. It can be observed in the formula for calculating the volume that the maximum and minimum values each of red, green, and blue are utilized in the construction of the V box. These maximum and minimum values are obtained from the pixels of the image inputted in the system. To quantize these pixel intensities, we take the longest side of the cube and slice it through the fittest point. Now, to find the location of cut, we use a fitness function that utilizes something called as the color index. The function getColorIndex helps in defining the color index of the pixel values, which were inherently in the form of R, G, and B. So the small r, g, and b are the values we input. The double left arrows indicate the bitwise left shift operation, and sigbits are the number of significant bits. This gives a single value representation for the intensity values. Now, using this, an histogram is created, which records the frequencies of the color indices. Now, moving back to our fitness function, it takes in the color index and calculates its fitness based on partial sum and look ahead sum. These are calculated using the frequency values present in the histogram. Now, once we have the fitness value of all the color indices, we know the one with the highest fitness is to be selected as the point through which the slice is made in the cube. Now, this process is repeated once the slice is made. Now, the two V boxes obtained are further divided into the same process using the same process recursively, which can be visualized as a binary tree that we see in the diagram. Our leaf nodes bear the final quantized colors. The termination criteria for the recursion is the number of significant colors that we require, that is basically the desired number of leaf nodes. Now that we have understood color quantization, color mapping is simply done using the Euclidean distance formula for 3D space. This helps us to find the similar colors that will potentially look good with the room's color context. Now, next, let us look at an example. So these are the input images and their corresponding extracted colors, followed by the personalized color palette. Next comes the most interesting part, which is the implementation. Here we see our home page. So once the user logs in, we can see this homepage with the furnitures and their name, their price, and their image. Now, whichever type of furniture that the user wants to buy, they can select on that particular card, and that card directs you to a product details page, which we see in the third image. So in the product details page, we have an option to add cart. Once you add cart, you can see in the second image, this is how the look of the cart is. We have view in AR feature. Once you click on the view in AR mode, you land on this page called the local and web objects. And there is an indicator that tells you to move your mobile phone. And once you move the mobile phone, uh, at one point you will see a marker which will tell you that now uh, the AR service has detected the presence of a plane. And below the screen, you can see a button, add or remove the object. Once you click on that button, the object is instantly displayed in 3D in your room. Apart from that, our main part, which is giving the recommendations, there is a button on top that says go in recommendations. So once you click on go to recommendations, there is a drawer that opens up and you can enter the maximum length, breadth, and height and the category of furniture that you want to choose. You can also either upload an image from your gallery, or you can click an image right then and there and click on submit. Once you click on submit, the API to our system is triggered and the output is displayed on a new page called as the recommended furnitures. Below the recommended furnitures, now you have an option to rate and view the chart that shows the rating. So this is part of our testing. So once you click on rate, you have an option to give ratings from 1 to 5 stars. It can be decimal ratings as well. And once you submit, the ratings are recorded along with the user's profile, uh, that is their age and their gender. So at the bottom of the screen, we are also displaying the average ratings as of the current ratings that we have obtained. The next, if you click on view charts, you're directed to a page which has these two charts, gender-wise average ratings and age-wise average ratings. So this is part of a result analysis. We have collected 50 ratings and their average rating so far has been 4.5. And our gender-wise distribution is male, female, and others. And age-wise distribution is 10 to 30 years of age, 31 to 50 years of age, and 50 plus age. So as we can see, the ratings are quite promising. So next, we would like to conclude this on a positive note. Sanika, please take over.
So in conclusion, the implementation of color-based recommendation algorithm within our furniture recommender system has shown promising results, enhancing user experience and facilitating more personalized choices. So these are our future scope. First is enhanced AR integration. Features for extracting dimensions of space would allow users to accurately visualize how furniture fits into their specific room dimension, enhancing the virtual toy experience. Second is consideration of other room aspects. Currently, we are only considering the color aspect, but more, more more features like lighting conditions, existing aesthetics, and spatial layout can also be considered. And the last one is more enhanced interior design assistance. Incorporating more factors into the recommendation process. This includes considering how recommendation furniture pieces can optimize room spaces, making it look more luxurious, spacious, the way the user wants, according to the user's preference. So this is it. Thank you. Next slide.
Thank you.